Hello everybody. So today we're going to learn about the two terms parallel and perpendicular and what they mean in terms of lines. So the first one we'll look at is what a perpendicular line is. The definition of a perpendicular line or two perpendicular lines is lines that are right angles to each other. So what this would look like in a diagram is two lines, and like we said, they're at right angles to each other, so they make an angle of 90 degrees with each other in here. So we can signify that using this symbol, like we discussed before, or we can use just normal angle notation and say that this is an angle of 90 degrees. So these two lines here, for example, we might call them the line L and the line K. And we could say that the line L is perpendicular to the line K. And this is the mathematical notation we'd use. If you look at the symbol for perpendicular, it is just two lines that are perpendicular or making a right angle with each other. Our next term, parallel lines, talks about two lines which will never meet. So what this would look like in a diagram is two lines like this. We can call these lines A and B. Now these lines can go on forever, and it doesn't matter how far they'll go, those two lines will never cross over. Like for example, these two lines here. If these two lines continue, they eventually will cross. A and B, on the other hand, will not. They'll just stay the same distance apart the whole way along, and they can just keep on going on forever without meeting. The way we show this in a diagram is by putting in two arrows that go in the same direction. So this just means that those two lines are perfectly parallel. And if we wanted to use mathematical notation to describe it, we would say that A is parallel to B. And notice that the symbol for two parallel lines is just two parallel lines in the middle of the two names of the lines. So A is parallel to B. Now we have two more bonus terms to discuss in this video. One of them is horizontal lines. So horizontal lines are lines that are parallel to the horizon, or sometimes we describe them as lines that are parallel to level ground. To help us visualize this a little bit better, let's bring in a picture. So here's a nice picture of a beach with a very visible horizon off in the distance. So any line that is horizontal will be parallel to this line of the horizon. So if we wanted to draw an example, we could say that this green line here is horizontal because it is parallel to the horizon. And we could also draw another line here that we could call horizontal because again, this line is parallel to the horizon. And finally, we'll draw one more line here, which is again parallel to the horizon. In fact, all of these lines are parallel to each other because they're all going in the same direction and none of them will ever meet. If we were to draw one line that was not horizontal, I'll do that to the left hand side. So this line here, for example, is not horizontal because it is not parallel to the horizon, because it would eventually cross the horizon if we extend both of these. The final term we're going to learn about today is the term vertical lines. So a vertical line is a line that is perpendicular to the horizon. So again, we're going to get our image of a horizon in here to help us out. So any lines that we draw now that are vertical, remember I have to make an angle of 90 degrees or a right angle with our horizon. So if we start drawing some examples of this, we'll go to our horizon. We can draw one line here that is at 90 degrees to our horizon. So if we look at this, the angle it makes with the horizon should measure 90 degrees. Or again, we can denote that by showing this symbol here. And if we want to draw another one, I might draw this one in green. Here's another example. Again, the angle it makes is 90 degrees here. And we'll draw one final example now. This time we'll draw it up in the sky. So this angle here also counts as vertical because it is at 90 degrees to the horizontal. Now, I know we don't actually see where it joins the horizontal, but we know that if we extend that line down, that it would make an angle of 90 degrees when it eventually reaches the horizontal. So that also qualifies it as being vertical. The last thing I wanted to do before we finish the video is to look at the 4 palm trees here. 3 of these palm trees are vertical and 1 of them is not. So what I want you to do is pause the video for a second and try and identify which of those palm trees is not vertical. Okay, so if we look at each of these different palm trees and look at the angle that it makes compared to the horizon, this one here looks to make an angle of about 90 degrees. The second one from the right also looks to make an angle of about 90 degrees compared to the horizon. The one on the far left, we can say the same. The only remaining tree actually looks like it's slightly off vertical. It is close, but the angle that this makes actually is not a perfect 90-degree angle. And we can see this if we look on one side, it's slightly smaller than 90 degrees. If we look on the other side, it's slightly bigger than 90 degrees. It's probably easier just to tell by looking with your eye, though. You can see that this doesn't exactly line up as being at 90 degrees to the horizon. For example, if you were to see a house that was leaning over at this slight angle, you'd know that that house was not perfectly upright or perfectly vertical.